Okay, finally, we're going to talk about means with intervals. So when a set of data is basically so big that it has to be, or so precise that it has to be grouped in intervals, what we can do is we can actually just approximate the mean using the mean formula here. So if we take a look, what we're doing is we're going to multiply the frequency, so how many times that number shows up, by the midpoint. And then we're going to divide it by the frequency. Again, mu is for the population, x bar is for the sample. Okay, m is the midpoint, so that's where the approximation comes in. Is it 1? Is it 2? No, we're going to actually just use 1.5. We're just going to approximate it at 1.5. Okay, and f is the frequency. Similarly, with medians with intervals, we can estimate the median for group data by taking that midpoint. So whichever interval the median would actually fall into, we just take that midpoint. We can do this by analyzing cumulative frequency. So we'll take a look at that. Okay, so here's our example. A group of children were asked how many hours a day they spend watching television. Okay, right here, this is the results. Let's go red. Red's going to show up on blue better. Okay, that is the results. Okay, 0 to 1 hours, 1 child, 1 to 2 hours, 4 children, 2 to 3 hours, 7 children, and so on. Okay, so first, what this wants us to do is determine the mean and the median number of hours for this distribution. So all I did is I took this chart and I split it up here, number of hours and the number of children. So basically that's a frequency, right? Let's fill in the midpoint. So the midpoint between 0 and 1 is, 0.5. 1 and 2 is 1.5. 2 and 3, 2.5, 3.5, 4.5, and then 5.5. So these right here are all just like the midpoints. Oh, and that should be M. Okay, cumulative frequency. So what the cumulative frequency is adding up the frequencies and continuously adding them. So between 0 and 1, up until now, we've accounted for 1 child. Now, up until now, we've accounted for, we add them, 5 children. And we add another 7, so up until here, 5 plus 7 is 12. We've accounted for 12 children. And then plus 3 would be 15, plus 2 would be 17, plus 1 would be 18. The total here is 18, and we're going to come back to that. Now, M. I'm going to put M for the midpoint. So let's multiply the Fi and then Xi, because then what we're going to do is we're going to add them all up after, and we're going to get the sum of all of these, which is the numerator in our equation. So 0.5 times 1. So I'll do this in another color. 0.5 times 1, I get 0.5. 1.5 times 4, I get 6. 2.5 times 7, I get 17.5. And we're going to multiply all these. So 3.5 times 3, I get 10.5. 4.5 times 2, I get 9. And 5.5 times 1, I get 11. Now let's add these up. 0.5 plus 6 plus 17.5 plus 10.5 plus 9 plus 11. I get 54.5. So what we're going to do, so it says a group of children. So I'm going to use the X bar formula because it's not every single child, it's just a group of children. I'm going to consider that a sample. So let's take a look at the equation again. So what we want to do is we want to use the sum of FIMI at the top and then the sum of FI at the bottom. FIMI at the top and then the sum of the frequency at the bottom. So FIMI is right here, 54.5. Over the frequency, well, the total number of the kids is 18. So the average here, the average number of hours that these children watch is, I get 3.03. So let's just round to 3. Is 3. And that's just approximate. So if you notice there's a dot on top of this equal sign, it's just approximate because, again, we use the median to, sorry, the midpoint to approximate that number. And next, median. So when we're calculating the median, okay, we have a total of 18 students. So if we, or 18 children, if we divide that by 2, we're going 9 values in from each side. So what we're going to do here is like, so this is 1 value plus 4 is 5 values. The 9th value falls here. So what we do for this is actually we take the 8th value and the 9th value and we average them out. So it's 8th plus 9th. We average them out. Both of those fall here because these values here go between 6 and 12. So this interval here represents up to the 5th child, and then this one would represent the 6th, 7th, 8th, 9th, 10th, 11th, and 12th child. So the 8th and 9th child are both going to be from this interval. So let's approximate between 2 and 3. So the median, let's say, is 2.5 because that's the midpoint. Again, for B, we've already talked about this, but these are simply approximations because, again, we are using the midpoint.